Hey guys, so here is our example 4. It's very similar to example 3. Actually, the remaining examples in 4.1, they are very similar to each other. Direction for example 4 states, use analytic methods to find the extreme values of the function and where they happen. Similarly to example 3, okay, first, always find the critical point. Find critical point. Then critical point is the derivative. So that's going to be 3x squared minus 2. Make sure we set it equal to 0 because our job is to solve for it. We get 3x squared equals 2. Divide both sides by 3. So x squared equals 2/3. Then we're going to take a square root. So x equals plus or minus square root of 2/3, which is plus or minus square root of 6 over 3. And if we were to use our calculator, it's plus or minus about 0.82. Second step, it's always, the only difference here is we don't have an interval. So what we want to do is plug in your critical point since we don't have endpoints. Plug in critical point slash endpoint into your f function, your original function. Well, we only have 2 points, the plus rad 6 over 3 and a minus rad 6 over 3. So first one, we'll do rad 6 over 3, which is third root to the power of 3. So rad 6 over 3 to the power of 3 minus 2 times rad 6 all over 3. And we're going to add 4. Let's see. This will give us 6 rad 6 all over 27 minus 2 rad 6 all over 3 plus 4. Since the common denominator is 27, let's make them all into a denominator of 27. Let's make it all into a denominator of 27. So what that means is I'm going to multiply this guy by 9, and if I'm multiplying this guy by 27, so that will give us, here we go, minus 18 rad 6, and 4 times 27 is going to be 108. Now we have a negative 12 rad 6 plus 108 all over 27. We can do a couple of things. Looks like we can take out a 3. So that will give us a negative 4 rad 6 plus 36 all over 27. That will help. So negative 4 rad 6 plus 36 all over 9. And if we were to use a calculator, it's about positive 2.91. So that's just the positive rad 6 over 3. We would do the same thing to the other critical point of f. Sorry, frozen on me. There you go. F of negative. Let me wait for a second so that way it's thinking. So f of negative rad 6 all over 3. I'm going to move it up so we can see. And we're just going to do exactly the same thing. We know that the common denominator from the earlier algebraic work is 27. So I'm going to go straight there. Equals, if it allows me to write, equals negative 6 rad 6. I'm skipping the plugging in part and going straight to the common denominator. All right, let me just pinch it in a little bit. It's frozen on me. There you go. Negative 6 rad 6 plus 18 rad 6, if it comes up. No, it's not responding. That means it's frozen. Okay, plus 18 rad 6 plus 108 all over 27. It's coming. It just frozen. There you go. Then from there, similarly, we combine like terms, we factor out the 3, we reduce it. This is going to come out to be now a positive 4 rad 6 plus 36 all over 9. And if we were to use a calculator and it is not responding, that means it's freezing on me again. That's going to come out to be about 5.09. Oh, geez, come on. Sorry, guys. Technology issue. Okay, so as you can see, I'm going to pinch it in so we can see both y values. One y value is at 2.91, and the other y value is 5.09. Now, don't think that the higher the y, that's automatically a maximum value. That is not always true. So since we do not know which one is the higher value and which one is the lower value, I am going to make myself a number line. I like number lines because it helps me visualize and organize my information. So let's see if it's going to let me even draw my number. There you go. Slowly, okay, there you go. There are the x locations. I'm going to write x. We have, okay, then, okay, so first things first, we're going to write in our two x locations. The first was a negative radical 6 all over 3. The second is a positive 6 all over 3. And obviously, in between a negative and a positive, there is a 0. And all I'm doing is, hey, when I plug in a number on the left side of negative rad 6 all over 3, such as f of a negative 100, I'm trying to see, is it higher, okay, than the y value we found, or is it lower? That's all I'm doing. I don't really need to know the exact. Okay, let's go. And since I plug in 0, I'm just going to find the y value of that as well. And then I'm going to plug in a value all the way to the right side of rad 6 all over 3. Okay, so, well, f of 0 is quite easy to find. Let's find my equation really quickly. If you plug in 0 for x, it's immediately 4. So not a big deal. And we found earlier the y values of negative and positive rad 6 over 3. So the first one was, let's plot that really quickly. Okay, when x was a positive rad 6 all over 3, y was about 2.91. So I'm going to make it right there. F of 0, we just did that. That was 4, so it looks like that. Oh, I just plotted the wrong side, didn't I? Negative. When it was negative rad 6 over 3 was 5.09, so it's higher than 4. And then when x was positive rad 6 over 3 was 2.91, so it's down here. Now the question is, on the negative infinity and positive infinity, the end behavior, is it going downward or is it going upward? So that's where we're trying to find. So when x, it's a negative 100, all you guys are trying to do is really checking to see if it's going to be positive or negative. Here we go. Your equation was negative 100 to the third minus 2 times negative 100 and then plus 4. So this right here, that's the powerful term, that's the dominant term, that's the end behavior term. So because that is a negative, this will always be negative. Remember, we talked about these two terms right here not being very important or relevant to the end behavior. Then, same thing with 100. We're going to plug in 100 to the third minus 2 times 100 plus 4. So technically, you're just looking at this first term in a polynomial. So that will give us a positive. So that means it's going to go above and below. So if we were to sketch this out a little bit, this side will be going this way, and this side will be going like this. So this is just a quick sketch, okay? Like that. So if we can sketch that out so easily, right? Just knowing the end behavior. So now that we have the end behavior, we can now decide which one is the max and which is the min. And it's not an absolute max, it's just a local max because it's not the highest of the highest since the end behavior keeps going up forever and down forever. So we have an answer already. You have a local max. Local max is right here. Local max was, so is 4 rad 6 plus 36 all over 9 at negative rad 6 all over 3. Then local min is negative 4 rad 6 plus 36 all over 9 at positive rad 6 all over 3. And box that up. Now, some of you don't need to do the number line to visualize it or see it or write the answer, but if you have an issue with organization, then a number line is a great way. Let's try example B. Similarly, I'm no longer writing out the steps for you. I'm just going to work it through. First things first is find the critical point by finding the derivative and set it equals to 0. Factor out your 3, so that's x squared minus 2x plus 1 equals to 0. Try to see if you can solve by factoring, and your two factors are identical. So as you can see, there's only one x value for your critical point. Then the next thing is, hey, plug in the endpoints or the critical point. Since we don't have endpoints because they didn't give us intervals, so you only have one x value to plug in. F of 1. So 1 to the third minus 3 times 1 is 3 plus 3 minus 2. That's going to give us a negative 1. Again, since there's only one point, it is very difficult for us to determine whether it's a min or max. So make a number line. Here's x. We have x was 1 and y was negative 1. So I'm making that dot down here. Well, let's test the end behavior. I'm picking negative 100 and I'm picking positive 100. And all we're checking for if it's negative or positive. So again, because the first term is a cubic, so it's going to be a negative 100 to the third. That will always be negative. This is positive 100 to the third. That's always going to be positive. It means that this is always going to go on the left side, always go down that way, and the right side always go that way. Okay. Now, because your point 1 comma negative 1, okay, the point was 1 comma negative 1, by definition, it's not bigger than all the points, and it's not bigger or not smaller than the rest of the x's. You do not have an extreme value. No extreme value. Okay. Now back in Algebra 2, we call this an inflection point. That means it's not the highest and it's not the lowest. Okay. And later in the next section, we are going to, I don't know what section it was, we are going to use the inflection point for something else altogether. And this is the end of example 4.